Hey guys, today we're going to have a look at image augmentation as related to computer vision tasks, or more importantly when you're training your deep neural nets using convolutional neural networks or something else. And most of the time you have the problem that your model is actually learning only from the data, and if the image is like slightly different from the image that you've trained your model on, then your model might not perform as you would like. So this is the general problem of generalization, and most of the time when you train your models, they just perform well on the training data, and they do not generalize good enough for real world examples. So there is this survey on image data augmentation for deep learning. It will be linked down in the tutorial and the source code when they're ready. So as you can see, this is like quite a big survey, but it's really detailed, and the problem of not having enough training data or not enough representative training data is roughly described in here. What you want to do is to have this type of convergence between the training and the test error. So this would be an ideal scenario, but most often than not, your models are actually starting to overfit when they have like not enough examples. So basically you can combat the overfitting problem in a variety of ways, but one of the most robust or probably easy to do ways is to just put more data, and this works really well in practice, but the data has to be like not the same, or the data should be representative of the real world data that you're going to use for your when trying to do inference with your trained model. So most of the time you end up in a condition something like this. So in this situation, what you can do when training, for example, for image classification or object detection or image segmentation problems, some of the time you can just go and get more data, and that would be ideal. But most often not, the actual process of annotating the data is quite slow. You might have to pay for it, and you might not just be able to get more data. So what do you do then? One thing you can do is to use image augmentation techniques, and those techniques are summarized pretty well in here. Let me show you the diagram. And as you can see, this diagram shows that there are basically two huge types of image augmentation techniques or manipulation techniques, and one of the ways is basic image manipulation. So you can do random erasing, mixing images, shifting the colors, rotating, or using some kernels or whatever. And this tutorial is primarily interested in these basic image manipulation techniques, and we're going to use a library called Albumentations. So I'm going to show you how to basically use this library, and I'm going to create a sample dataset that you can use with the augmented images today. And the other, like, more maybe cutting edge approach is to use deep learning or use basically backpropagation to create images that are not like easy to understand how the process goes from the basic image to the resulting image. So you can do neural style transfer, you can do adversarial training, or using GANs for data augmentation. Most of those approaches, however, have maybe, let's say, they have practical issues, and one of the practical issues is that, well, you have to train even more now based on those, just to get a model that can do that. And like a really cool paper that came out of the Google Brain team is the Learning Data Augmentation Strategies for Object Detection. It was published like June this year. Yeah, we're still 2019. So in this year, we had this paper published from the Google Brain team, and basically they show that they can use, they can learn augmentation policies, so they can learn automatic ways to transform, to augment images, and based on that, you can see that the performance of the model. Here we have mean, average, precision, and we have on the x-axis we have the number of training examples, and the red line describes the performance of the model when they employ data augmentation or image augmentation techniques, and the black line is without the augmentation. So as you can see, even when training with like these highly complex models, you can see that the image augmentation have like really a good improvement based on just some learned augmentation strategies. And this paper is really cool. You can have a look at it in more details, and you can see some of the augmentation techniques that they've used in here. And of course, this paper is related to the object detection task that we've discussed in the previous video. And you can see a couple of transformations or augmentations, and they look like they're pretty interesting, I guess. So yeah, this paper is really good. Another paper that is really that came out during this year is surveying the face data augmentation problem, and in here you can learn about strategies that are specific for detecting faces. So this is another task that is really important for computer vision guys, and this paper describes a lot of tools and methods specifically for this type of task. Okay, so the last thing that I wanted to show you was in the survey paper, they had another chart in here that describes the performance of the models with and without augmentation. And another interesting thing in here is that they say that when you are adding augmented data or augmented images to the test set, the performance improves even the performance improves a bit even more. So this is pretty crazy to me, and you can delve deeper into this type of augmentations. And this survey actually is referencing a lot of papers, so you might want to dig a lot deeper into that. So let's have a look at the library that we're going to use today for data or image augmentation. And we're going to to have a look at this library and use it in practice to use some data augmentation techniques on a simple image. Okay, so the library, as I've already said, is called Albumentations. So this library, it has a paper linked to it, Albumentations, fast and flexible image augmentations. Those are the authors. I'm not going to say their names, but yeah, you can come and check out this paper in which they introduce the library. The library is really well developed. It has 4.1k stars on GitHub currently, and it's like really well maintained. They have notebooks, examples, whatever. So the cool thing about this library is that it's really easy to use. So you have to use this library. You can actually use this library with Keras, TensorFlow, PyTorch, or whatever image augmentation deep learning library you're using, or maybe you're not using deep learning library. You can use even augmentations without deep learning library. And like there are no dependencies to any of those libraries, and this library seems to be pretty fast based on the benchmarks that they describe in here. You can see that Augmentations is compared to some other libraries, including Torch Vision, Keras, Keras. Okay, Keras, and the different type of augmentations. These numbers describe the number of images that you can process in a single second, in 1 second. And for example, let's have a look at vertical flip in Keras is quite fast. Augmentation beat that by just a tiny margin. Torch vision is like really slow. I'm not sure why, but yeah, Torch vision is actually with a pure SIMDB backend, whatever that means. Okay, so you can have a look at this benchmark. I'm not primarily interested in performance at this point, and when you're building toy data sets, the performance will not be an issue. The most important thing will be like, is this library easy to use? And fortunately, this library is really easy to use, and I'm going to walk you through the process of setting up and using some of the transformations or augmentations. Okay, so there are some examples in here. You can see that you can have the task of object detection and the bounding boxes in here in the original image, and when you, for example, crop some part of the image, you can see that the bounding boxes are preserved, which is pretty cool, and we're going to have a look at how we're going to do that. The same thing goes for the mask when you're doing image segmentation, and as you can see, the crop is really preserving the mask, so that's like pretty cool thing, I guess. There are some brightness or RGB shift, contrast, gray, blurring, whatever. So we're going to have a look at most of those, and let me just start by firing up Google Collaboratory Notebook, and in here I'm going to first check the runtime type. I'm using Python 3 and I'm using GPU. I'm not sure if this will matter for this example. And the first thing that I'm doing in here is to get the latest Albumentations version of the library. I'm going to use pinstall upgrade. So after that, we are going to do a bunch of imports, and the source code will be linked down below, of course. So we are having a lot of imports in here. And the next thing that I'm going to do is to download a zip file containing 2 documents that we are going to work with. Actually, we're going to work with only one of those, but you can like exercise on the other. So let me just grab the documents. They're stored on my Google Drive. You can use whatever source that you want. And I'm going to unzip the documents. And now, when I always into that, you are going to see that we have the form and license images, and I can go to the files and open the form image. Okay, so you can see the form. Yep, that's the form. It's a student name change form, whatever. It has some student ID, first, middle name, whatever. And when you change your name, maybe you have to fill in this form. So let's say that you have the task of extracting the student ID from this form. So this is the field right in here. So you have an object detection task, and you have to specify where the student ID is. And after that, you can use some OCR or whatever to extract the actual number. But first, you have to find where the student ID number is. And then you can like crop that information out and just take the number with OCR, of course. So how can you approach this problem? You can train a model for object detection, as we've already discussed in the previous video. And after that, you can evaluate on a test set and have a look at how good your example is. But let's say that this type of forms are, you have like a really small data set. Maybe you have like 1,000 examples or even 100 examples. and you might want to do some image augmentation to get a better test error based on the data that you have. So let's say that those type of documents are scanned and sent to you, and as you can imagine, not every scanned document will look like this. You know that if you have heard of scanned documents, and if you've ever seen scanned documents, you might have guessed that most of those have some rotation, or they have like slight change in the colors based on the scanner that is used. So the type of documents that you can see that are scanned, even though if they have the same template or the same form, might be completely their looks might be completely different. So you might want to have to do some creative data augmentation and enlarge your dataset in the hope that your model will perform better in the real world. So let's have a look at how we can do that using Albumentations, and we're going to work specifically with this form. The other document that we have in here is some license, driver's license, that is. Let me expand that if I can. Okay, so this is a dummy driver's license or whatever. So you can do some of the same transformations that we're going to do for the form, and you can explore this document on your own, but I'm going to stick for now with the form. So let me start with defining where the bounding box for the document for the student ID actually is. So this will be this right here. And I've manually annotated this, and I have the coordinates for that. So let me just start with a function called show image. So this function is going to be defined as such. It accepts an image and a bounding box. So in here, I'm going to use OpenCV to transform the image into a form that a Pplot understands, and I'm going to simply show the image along with the bounding box on top of it. So to do that, I'm going to first visualize the bounding box, and I'm going to do that by calling a function visualize bbox. And we're going to have to write this function in a bit. And I'm going to make a copy of the image, and I'm going to pass in the bounding box. The next thing that I'm going to do is to create a figure which will basically describe how big the image is going to be displayed as. And in here, I'm going to specify that we have a width of 18 and a height of 12. The next thing that I'm going to call is the image show, and in here I'm going to use OpenCV and convert the image to RGB format. This is the format that actually the Pyplot understands, and I'm going to pass in the image, and then I'm going to specify that I'm going to convert the color from BGR, which is the default color, which is the color scheme or whatever that OpenCV uses, and I'm going to convert that to RGB. And I'm going to use interpolation, so this should make the image a bit look a bit crispier. So I'm going to use the nearest neighbor interpolation. I'm going to remove the axis because we're just displaying an image. I'm going to request a tight layout around the image, and finally I'm going to show the thing. Okay, so you might have noticed that we need this function called visualize bounding box, and in here I'm going to start by specifying this function. And this function is going to take in an image, and a bounding box. So the other thing that this function is going to take in is the color of the bounding box. And I'm going to specify a default color of the bounding box, which is going to be black. You can change that. And this is going to be a triplet for the RGB colors. And the next thing that I'm going to specify is the thickness of the bounding box. So thick with triple C, I guess. And this thickness is going to be 2 pixels. Okay, so in here, the first thing that I'm going to do is to take the coordinates from the bounding box, x min, y min, and this is following the format that we've used in the previous object detection video. So I'm going to specify this one more time. And those values, I want those values to be integers. And to do that, I'm going to, just in case, use the int function to convert every value from the bounding box into an integer using the map function. Now that we have the integers of the coordinates, I'm going to use OpenCV and call the rectangle function, which is going to basically draw the bounding box for us. And we're going to draw this on the image. We're going to specify the x min, y min, or the top left point, then the bottom right point, which is going to be x max, y max. I'm going to specify the color, which is the box color, which is black, and the thickness, which is going to be the default value of 2. Okay, so you might want to beautify this a bit. Okay, let's say that this should work now. And we want to return the actual image from this. Okay, so we have now that those two helper functions. Let's actually read the form using OpenCV. To do that, I'm going to call the imRead function, and I'm just going to specify the path, which is form PNG to the image. In Google Co-op, you can use, at least when you are on the okay, this is the experimental editor, which allows you to use autocomplete. So in here you can autocomplete the file path. So this is just getting the form, and the form is read as an array. So this is just a NumPy array, and you can call the shape of that. And you have the width, the height, and the number of the color channels. So yeah, maybe yeah, it's actually, this should be the height, the width, and then the number of colors, because the form is like vertical. So okay, so the next thing that I'm going to specify is the bounding box, and I have the coordinates manually annotated. I took my time to do that. So this again is x min, y min, x max, y max. These are this is the format for the coordinates that we're going to use, and this matters a lot, and I'm going to show you why in a bit. So this is the bounding box, and finally I'm going to show the image, which is going to be the form and the bounding box that we've described in here. And when I run that, you can see that we have the form itself with the bounding box in the color of, oh, that's not black, that's actually 100% blue. So okay, that's cool. Okay, so we have the bounding box around the student ID, the value of the student ID. Okay, so this looks pretty good. And now the next thing that we want to have a look at is how to do some image augmentation to create our improved or augmented dataset. So the first thing that I'm going to show you is how to build a helper function that is going to display the newly augmented image. So we're going to call this function show augmented, of course. And this function accepts augmentation. Oh, let me zoom in this for you guys. I'm sorry. Okay, this accepts the augmentation, the image, and the bounding box. So we are going to first apply the augmentation to the image in here. And to do that, I'm going to call augmentation. And this is a bit of Albumentations, some part of the Albumentations API. We're going to have a look at that in just a bit. And in here, I'm going to pass in the image, the bounding boxes for this image. Of course, we have only a single bounding box in here. And the next thing that I have to specify is the field ID. We're gonna have a look at why in a minute. And the next thing is to call our previous function, which is called show image. And from the augmented result, I'm going to take the image and the augmented bounding box. So as you can see already, Albumentations takes care of augmenting not only the image but the bounding box around the image as well. So this is pretty cool, I guess. Okay, so the first thing that I'm going to do after we have this function is to define a variable called bboxparams, and this variable is going to specify what is the format that we're using for the bounding box coordinates. So let me start with that. Okay, and the format is going to be Pascal voc. This is just the format xmin, ymin, whatever that we've already discussed. Let me just paste in the format so that it's a bit clearer. Okay, so this is the format that we are going to specify our bounding box into. And I'm specifying some parameters for the bounding box. And we are going to label fields called field ID. So this field ID and this should be the same. I'm specifying this as field ID because this is a field in the form. You can call it whatever you like. Okay, so now that we have the bboxparams, okay, mean area. I have an error. Oh, I have a comma in here. Okay, so now that we have the bboxparams, we can finally do some augmentations. So what does augmentations look like? Let's start with a simple one. I'm going to compose an augmentation of just a single augmentation, and A refers to Albumentations import in here. So the first and like the most simple augmentation that we're going to do is to call flip. So flip the input either horizontally, vertically, or both horizontally and vertically. And you can see that we have a parameter called always apply, and I'm going to specify that as true. So we want to see the result from this augmentation. The next parameter that I'm going to pass into the compose is going to be the bboxparams that we've just showed or did. And then I'm going to specify the probability of applying this which is by default 1, so I'm not going to specify this. And now that we have the augmentation, I'm going to call the show augmented. I'm going to pass in the augmentation, the form, and the bounding box. And as you can see, we have a flip augmentation, and the bounding box is still at the correct spot in here. So let me run this again. And now you can see that the transformation is a bit different. Run it again. And we have the same transformation. So what does this thing actually does is to get this augmentation. Let me manually do that for you and have a bit of look. So if I take the augmentation and I call the image on that, it says that label fields are required. Field ID. Okay. Let me get this. Let me take this. Okay. So if I do that, I have to specify the bounding box too. Okay. Let me specify the students. And now, if we have a look at the augmented result, you have in here the field ID, the image, and the new bounding box. So these are the new coordinates of the bounding box, and this is the new image that you take from the augmentation. So you can, for example, just take the image, do PL image show, and this is quite ugly, but you get the idea. Okay, so you can take the image or the bounding boxes, and this is what we're doing in the show augmented function. Okay, let me just get rid of this, and let me just have a look at some of the transformations that we might be interested in. So these are the transformations that you can do at pixel level. So at pixel level you can apply some blur, random brightness, random contrast, random gamma, some graying of the image, RGB shift. You can change the values of for each color channel. And then we have spatial level transforms, and in here you can have a look at is this applicable when you have bounding boxes. So you can do crop, center crop, you can do some flips which will preserve the bounding box. You can of course do some rotations and rescaling, resizing, some shift scale rotations, some transposes, and all of this preserve the bounding box. So we have a document, and we can think of some important transformations for the document. So one of those would be the flip, which we already discussed in here. So this is a pretty good start. The next thing that you might discover when you actually work with augmenting, or when you work with documents, is that some of the time they're rotated. So yeah, let's have a look at the rotate transform, and as you can see, the result is rotated by some degree transformation, and you can see the bounding box is actually preserved, but the bounding box is not rotated as well. So this is pretty interesting, and based on the model that you are going to train, your model might handle rotated bounding boxes or it might not. So this might be something that you want to configure. Okay, so let's have a look at some other transformations. And most of the time when you're working with scanned documents, you might have a different gamma. So let me show you what I mean by that. And I'm going to call in the random gamma, and I'm going to specify a gamma limit between 400 and 500. And as you can see now, the document is really not that well saturated. So this is like really common when you work with scanned documents based on the scanner or the printer that actually printed the form or whatever. So this is pretty good transformation for documents, I guess. The next thing is going to be the random brightness and contrast thing. And I'm going to show you how to use that as well. Gamma, random brightness, contrast. Yeah. So yep, you can see that the whole picture is a bit darker, and we can run that again. Now it's a lot darker, a lot more darker. Okay. So you can just rerun this and get different type of transformations based on the random draw. And the next like really important transformation when working with documents is actually the RGB shift, because again, depending on the profiles on the scanner or whatever, the colors, and depending on whether or not you're interested in the colors, you might work with just grayscale documents, but you might be interested in the colors when the documents are passed in, will be the RGB shift. So I'm going to call the RGB shift transform, and in here we have a couple of parameters that are related to the shift for each color, and I'm going to specify the limits. I'm going to increase the limits actually. Shift limit, let's say 100. RGB. Okay, let me run that. And as you can see now that the thing is much more purplish, I guess. If we run this again, yellow. And of course, those values that I'm showing you right now are some values that are highly exaggerated, so we can understand what the transformation is doing. When you are developing your transformations, you must carefully choose actually those parameters, and they should make sense for your particular problem. So maybe when you work with RGB shift, you will not specify such high values. And I just want to complement the Augmentations library, because most of their default values are like really make sense. So these are picked very carefully, in my opinion. Okay, so we've looked at some of the augmentations that are presented in the Albumentations library. The last one that I'm going to show you is the Gauss noise parameter transform augmentation. So in here I'm going to specify the variance limit, which is, let's specify this as like, let's say from 50 to 200, and the mean is going to be, let's say 20. Let's see let's have a look at a result from this. This looks okay. Let me increase that. Okay, so yeah, you can see the result from applying some noise, Gaussian noise that is, and you can see that the document is really much like not readable at all. So this is another good transformation that you might want to consider when doing some document data augmentation. So most of those augmentation were picked, of course, by me because they make sense when you're working with documents, and you really have to choose your own for your domain, as I've already described. Okay, so now that we've had a look at some individual augmentations, let's actually convert this process into something that is really geared towards preparing a dataset that you can use for training your models. And of course, in the previous video, we've already discussed how you can do the preparation of the dataset. But in here, I'm going to show you how to create the augmented dataset, and maybe you can train your models with that. So the first thing that I'm going to do is to build a transformation that is composed of multiple possible augmentations, and I'm going to call that doc augmentation. And this is going to be composed, of course, of a couple of augmentations. And I'm going to specify the bbox params in here. So let's choose some. Let's start with the flip transformation. And in here, I'm not going to specify the always apply true, but I'm going to specify some probability at which this transformation should be applied. So I'm going to say that every 1/4 times this flip is going to be applied. Then I'm going to do some random gamma. I'm going to specify a limit for that. That makes sense for this example. And yeah, I want half of the documents or the transform document to be applied with some gamma correction. Then I'm going to specify the brightness contrast thing, and I want most of those documents to be transformed using this. Then I want the rotate, and I want to limit this at 35 degrees. And in my experience, this is really common in the real world. So I want like a lot of the documents to have some type of rotation, because mostly if you have a clean data set, your dataset is not going to be rotated. And if that is the case, you need to rotate a lot of images so your models can pick up the rotations correctly. Then I'm going to apply another rotation, which is rotation by 90, random rotate 90. So in here, I want some of the documents, again 1/4 of the documents, to be rotated at 90 degrees. Then I'm going to apply the RGB shift. And note that in this particular document, you might want to work with just grayscale images. But in general, if your documents have color and the color signifies something really important, let's say you're detecting logos or whatever in documents, then you might want to do this RGB shifting, because again, some scanners or printers or whatever or phones might deliver different colors to the scanned images. And I want 75% probability of applying this with the default parameters. And the last thing that I'm going to apply is the Gaussian noise. This looks really important or useful in the context of scanned documents. So this is the augmentation, the composition of augmentations that I'm going to use for the dataset. And I'm going to show you one example of this, and then we're going to generate a lot of examples and actually save those. Okay, so let me grab something that's not rotated. Okay, so this is a sample augmentation. You can see that we have some brightness contrast, We have a flip. We don't have a rotation, I think. Let me take another one. Okay, no rotation as well. Okay, this one, it has a rotation. It's quite severe, which is great. And as you can see, the bounding box is preserved. This might actually give a hard time to the OCR, but whatever. Okay, so this is pretty good, I guess. So the next thing that I'm going to show you is how to create a dataset out of this. To do that, I'm going to first generate some augmentations, and then we're going to use pandas to create a data frame and save this data frame, which is going to contain the annotations for the dataset. So let me start this bit with documenting what I'm doing. So in this dataset, I'm going to use the following format. So the first thing in the CSV file that we're going to store is going to be the pandas data frame, is going to be the path to the image, x1 or xmin, ymin, xmax, ymax, and the class name. We have only one class name, which is going to be the student ID field. And we are just interested in that one in here. So let me start by specifying the path to the dataset. I'm going to specify the path to the dataset, then I'm going to specify the path to the images in the dataset. I'm going to make those folders, and I'm going to show you how those folders are actually exist. So I'm going to put that in data augmented, and I'm going to specify the images path. Okay, so those folders should be created with make dirs, and I'm going to specify that exist OK is true. Okay, and now if I execute this, make dirs, okay, and now if I refresh the local data system, the file system, you can see that we have the data folder, augmented folder, and in here we have the images folder. So this should be okay, and if I rerun this, it should be fine because of the exist okay parameter. Okay, now that we have our folders, I'm going to specify a variable called rows, and this variable is going to contain the rows for the data frame of the annotations that we are going to create. And in here I'm going to do a for each loop, and I'm going to specify that I want, let's start with 5 images, something simple. And the first thing that I'm going to do is to get the augmentation, create the augmentation, that is, apply the doc augmentation on the form image, give the B boxes, and specify the field ID, which is going to be 1 for every example. Then I'm going to create a file name, and this is going to be the augmented form, and I'm going to use the index of the loop, and this is going to be the file name of the newly augmented form. And for each bounding box in the augmented result, and note that we are going to have, for our example, just a single bounding box, but when you're developing more generic dataset, you might want to loop over each bounding box in here. And from here, I'm going to take the XY mins and max, and I'm going to refer to the map function that we've used. Let me just go grab that. Okay, so here we have it. All right. And then I'm going to append a new row for each bounding box. And in here, I'm going to use this notation. So file name is going to be the path to the images, file name. X min is going to be the X min. Let me copy paste this. Okay, this is the max. Max. All right. Max. Okay. And the class is going to be just student ID. So now that we have the rows ready, I'm going to actually write the image or create the image, and I'm going to use OpenCV in write, and in here I'm going to specify the path, and this is going to be actually images path, and then the file name. And I'm going to take just the image from the augmented result. All right. And finally, I'm going to create a data frame with the rows and save this into the dataset path annotations CSV file. So I want to have a header for that, and I don't want to save the index. So this should actually work. And to make sure that it does, I'm going to have a look at the files, run this thing, refresh again, and yeah, as you can see, we have a CSV file which contains 5 images, and we have the augmented images actually. So this one, let's have a look at it. Oh, this is amazing. Okay, so this looks like nothing like the original one, and yeah, your model should be really doing much better now that you have this. So the last trick that I'm going to show you is to actually import TQGM from TQGM, import TQGM, run this thing, and let's say, well, we can do like, yeah, let's start with like, yeah, 100 will be fine. And yeah, you can observe the progress in here using TQGM, and you might go crazy and do much more examples. And we're using Google Co-op, so this should run pretty fast actually, and you can create roughly 10,000 examples for like 15 minutes or so. So the Albumentations library is actually pretty fast. Okay, in the real world, of course, you will not be working only with a single document. You have much more, but let's say you have 1,000 examples, and then using the Albumentations library, you can create 10,000 examples or so based on the transformations that you're using. The last thing that I'm going to show you is this tool. Let me just show you. Okay, so this tool, Albumentations demo, is on the Heroku. Is deployed on Heroku, and the author is Ilya Warchenko from Moscow. So this dude has created this amazing tool which you can use to basically understand augmentation even better, and you can try the different tools, different augmentations. So you can posturize, you can change the red or the green or the blue. So this tool is pretty amazing actually, and when you're working with and this tool even generates the parameters that you use in here. So this thing, you can use that to explore and you can rerun even. Okay, that's great. You can use R to rerun the transformation, which is pretty amazing. Yeah. Okay, that's pretty cool. Okay, you can play with that, I guess. Oh, you can change the scaling. That's amazing. Okay. So yeah, you can use this tool to explore visually what the Augmentations library can do for you. And this should pretty much get you started with augmenting your datasets. Again, I'm going to link the tools, the papers, and everything in my blog post that is coming hopefully later today, and is going to include the source code for the augmentations that we did. Please like and subscribe this video, and show me what you've done in the comments section down below. Bye guys, see you.